Good morning, everyone. So today we are going to talk about pandas in more detail. So in the last video we discussed about series wherein we have one column and we have all the information regarding our column that is there. So now what we will do is we will go into data frame. So the data frame, the data is stored in a particular GitHub location. The location will be saved in the link below, and what we are trying to do is we are first of all we are going to import. So how it works is import pandas as pd. This is the file. Then we have to put the path. So right now it is there in GitHub, and then what we need to do is we need to use the function called read.csv, and we run this and we will get our head. So we want to see head. So I will talk more about head, but now this is the ways of importing. One way of importing, as we are using Colab, is directly putting the GitHub link of the CSV file. The other option is going to upload it using the google.colab import file command. So here what we can do is when we run this command, this link will be given and this file will also be shared with you. You can do choose file, and then you can go to that location where you have saved the data set, data science course. I have saved it in advanced Python. So student.csv, I have uploaded it here. After it gets uploaded, whatever name is showing here, so student.csv is saved. It is saved as student.csv. So whatever name is saved here, you can put like this. So first of all, it is uploaded in the drive. So you can see it is somewhere in the drive, right? Student.csv. And now what you do is you will go and read it and make it a part of df1. So this is just two ways of explaining, and now this is the whole data. It is basically a data of students' score, their obedient, their research score, and whether you will recommend them for a job or not. And we have only 10 rows of data, and this is with this simple data we will do our data analysis, and we will use the power of pandas to explore the data and see the different functionalities of panda. So now, as we told, this is one option that is there. There are other options also. When if you are using Jupyter Notebook, you can use the command, this command as well, wherein you can put the path where exactly your folder is. Now coming to the different options of viewing and inspecting the data. So I have mentioned we will go one by one. You can read all these details in the text here, but what we will do is we will go and see the details in the each cell. What we are doing by default, if we run df.head, what happens that we are able to display first 5 rows of data. If we put a number within the column, within the 2 brackets, as you can see, then what happens is you can limit the number of outputs that are there. So you can see there are now 3 outputs in this particular video. And similarly, if you do 1, you will get 1. This is the way you want to see if what is the output of your data. But ideally, when you work in real projects, the number of data rows are a lot, so it becomes very tough for you to see everything. So you need to use this command. Head is for the top, tail is for the below. So by default, if you use tail, you will get 5, and if you put a number within, you will get that specific number of rows. And if you just type the name of the data set, you will get all the data that is there. There is some restrictions. I think they show the first 10 columns, the first 10 rows of the data as well. So now suppose we want to see one particular column inside that particular data frame, we put it under a square bracket. Like suppose I want to see the overall grade for a particular student, right? All the student. So what we have to do, we have to first write the name of the data frame. We have to open the square bracket, and then we need to mention the over. So you just type overall, you can get this option here, overall grade, and then you enter. Then as you can see, you get all the overall grades here. Similarly for project score that you can give, there is one more way. You can also just do df dot overall grade. So this will also give you the output. So there are two different ways to do it. That is there. So we have showed here for project score as well. Shape tells us the number of rows and columns. Endim tells it is two-dimensional, right? Rows and columns is two-dimensional. Sample, what it does that when you do sample, it will return one either row or column, and it is sample. It's basically randomly generated, and if you put a number within the column, you will get that specific number. Now if you use df dot columns, the data frame dot columns, you will get the list of all the column names that are there. As you can see, the name, overall grade, obedient, research, project score, these are the name of all the columns that are there, and you can also save it as a list by putting a list and then declaring the column names. Info is a very useful function used to know the data frame summary. What are the number of columns, the names, the non-null count, and the t-type that is there. Describe, what does describe do is it gives us the numerical values that are there, statistical summary. It gives us of the value. Now you can see that there are a lot of zeros. So if we want to limit the zeros, because it becomes confusing with so many zeros, we can use the power of round function, wherein we can just do a comma 2. So what is this is going to do is it is going to round off the data accordingly. Similarly, if we want to see the similar data that you can see, it is in the table format. How you want to transport it into a column format, then you can use this particular scenario as well. Dot t. Similarly, we can use dot describe, where we can if we want to do a specific column, what we can do is we can call that data frame, and then what we can do is we can just do a dot describe. So now one thing that we want to say, that what is this 25, what is this 50, what is this 75. If I need to explain you this statistical summary, count is basically the number of rows that are there, number of elements that are there. Mean is, it tells us the actual, you can say the value, the average of that particular row. Standard deviation is a concept which we will discuss more in statistics and mathematics, but it is the talks about the variation. Minimum and maximum we know, 25, 50 and 75 are like quartiles, like percentiles. So first, if we divide the data equally, we sort the data accordingly and divide it by percentile. So we take the first 25%, the first quarter, the second quarter, the third quarter, and the fourth quarter. So that is how we talk about the percentiles. And there is one more, this is also called as a percentile, is from 0 to 100, but the 0 to 25 we call it as the first quantile. 25 to 50 we call it as the second. Similarly, 50 to 75 we call it as the third quantile, and the last quantile is 75 to 100, right? And there is a term that we use in statistics a lot, is interquartile range. It means the difference between the third quartile and the first quartile. So basically the second quartile and the third quartile added together is called a interquartile range. And now the things that I discussed earlier on, when we put quantile as 0.5, this is going to give you this particular quantile. 0.5 means this 50%. When you put quantile as 0.25, it is going to give you the this particular thing, first quantile. So this is the whole thing. When we say quantile is equal to 0.5, it is and making sure you're adding the first quantile and the second quantile. So 50 quantile is equal to first plus second. Similarly, this is only the first quantile, and 0.75 you have to add the first, second, third, and you can get the 75th, that is 82.5 in this particular scenario. So here we are doing the first quantile of both the numbers. So this particular thing, 82.5 and 71. So this is very important to do data analysis. Around the same thing that we are doing, we can if we don't need to put the name of the columns, if we don't want to put df.describe, we can also put df in 2 square brackets. We can mention the particular columns, and then we can do a describe. And now similarly if we want a specific parameter, like here we want standard deviation, we can put dot standard deviation, or if we want to put mean, we can just put mean and we can see the output accordingly, 55.7 and 48.9. So this is similar to the describe function. There are two options, as I told you. Just df.describe is going to show you all the statistical analysis for the particular column. Now we go back the same way. We can do rounding, right? We have a possibility of doing a round as well to remove the extra decimals. And if you want to get a particular parameter for a particular column, then you can select that particular column and do a dot mean and a dot count. And these are some of the things that you can do. And if you just do the df.describe.column, it is going to get you the list of the numerical columns. Now we have understood the analysis on numerical columns, and now we will go ahead and do analysis on the categorical variables. Now you can see that the name variable that is there does not give us any meaning statistically. So what we do is we drop it. Drop access is equal to 1. Why we use access is equal to 1? By default it is 0, access is equal to 0, but when we want to remove a particular column, then we have to mention that access is equal to 1. So we have to drop the particular column from the data set accordingly. So now what we do is we will be getting a data by like this without name. So now what we need to do, our objective is to remove the numerical values from here and do analysis on the categorical variables. So as we can see, we have object, obedient, and recommend. 3 objects we have which we need to work with. So what we will do is, first we will save all the columns in a set. Then we will save all the numerical columns in one particular other set of x.describe. Then we will subtract the first one from the second one to get the object columns that are there, the categorical variables that you can see: obedient, overall, grade, and recommend. To this, what we will do is we will save this to a variable called categorical underscore column, cat underscore column. As you can see, set x minus column minus x describe dot column. So we are subtracting the numerical column from overall column to get all the categorical variables. Now what we will do is we will just check this. We are getting the same thing, and now what we are going to do is we are going to subset our data. So there are two options that we are doing this. We can directly write all the object columns, but if the data set is huge and we don't know which are the numerical columns and we don't want to do this exercise, we can automate it by saving it into underscore column and seeing the categorical columns like this. So we are seeing all the categorical columns like this, and now we can do analysis on this particular column. So first thing is dot describe. When you do a dot describe, this is going to give us the statistical info of the categorical columns. So that is one thing that is very good. You know the count, you know how many unique values are there, which one is the top, and what is the frequency of that particular top item that is there. So as you can see in this particular row, this particular, if I can describe one numbers for you, you can see recommend has 10 counts, it has 3 unique values, and no has repeated 6 times. So that is one way you can do this. So you can do, if you want to show everything, then you can right now we have showed dot describe for the object functions, but when you want to do for everything, for even for numerical values, then you use a command x dot as type, and you mention object, and then you describe. So you will get that particular information over here. Similarly, if you just write include is equal to object, then you will get all the objects the same information to get the statistical information of all the categorical columns. So here you can see that to do one particular step, there are a lot of multiple ways. So in this video I am just trying to tell you the different ways to get the information and the statistical summary for numerical values that we have already discussed, and now for the object variables and how we can get it together. So our main aim should be to understand that the numerical analysis will be little bit different with mean, standard deviation and all those things, whereas categorical variables it will be different with count, unique, frequency. So but we need to make this small difference, and we need to analyze and see that syntaxes and how Python is helping us do the same. So we do all these steps, and if we want to run the code to get all the information, irrespective of whether it is a categorical or a numerical, we can just write include is equal to all. Some will be irrelevant like none, but it is understandable. Count will be there for everything, means will be there for the numerical value, and the count and everything, frequency, unique, frequency, top will be for the categorical variable. So now